This is example 4, lesson 2.7, infinite limits. We're going to investigate the limit as x approaches 2 of the function x plus 4 divided by x subtract 2. With direct substitution, plugging in 2 for x, we see that we get 6 over 0. 6 over 0 is undefined, so I know the limit's going to go to infinity, and I know that x equals 2 asymptote. The question is, what happens to the right-hand side and the left-hand side of 2? Looking at the graph, I can see that on the right-hand side of 2, my graph is going to positive infinity. It's going to negative infinity to the left of 2. So how do I prove this algebraically? The limit as x approaches 2 on the right of x plus 4 subtract x minus 2, I know is infinity because it's undefined when I plug in 2. But we're going to use a test point to see if it's positive or negative. So what's to the right of 2? 2.1. So when you plug in 2.1 for x, you're going to get 6.1 on the numerator, so that's a positive. You're going to get a positive in the denominator, and a positive divided by a positive is a positive infinity. So the next one we're going to do is to the left. We're just going to use a different test point. So we're going to sub it in. We know we're going to get infinity because it's undefined, but the test point that we're going to use this time is going to be 1.9 to the left of 2. When you plug in 1.9, I'm going to get positive in the numerator, but this time in the denominator, 1.9 subtract 2 will give you a negative. So that's why the left-hand limit is negative, which confirms our graph. So the limit as x approaches 2 of the function that was provided, because the left and the right are different, does not exist. But it's important to find the left and right hand limits because later on we're going to do graphing and we have to know the direction of the graph at that point of 2, which is our vertical asymptote.